Hi, so here is the promised part 2 of limits. Looks like you can see my screen okay. So the last two bits we have are one-sided limits and unbounded limits. So let's look at our one-sided limits first. Take that away. So here is a graph or a function that if we look at it at x equals 0, we have a breakdown. So I left this open so we could fill in the blanks. Oh, before I do that, so limit as x approaches c positive means we're approaching whatever our value c is from the right. So we're coming in, you see my mouse? No, you cannot, sad. Limit as x approaches c from the negative, we're going from the left. So we're gonna look at this absolute value of x over x as x approaches 0 from either direction. So let's plug in our values. Remember, the absolute value of -2 is +2. So +2 over +2, and excuse me, +2 over -2 is going to give me a -1. So this is saying if I plug in -1, I also get -1 for the same reason. If I plug in 0, we break down. Does not exist here. So I'm just going to put a big fat X there. Now, if I plug in 1, I get absolute value of 1 over 1, which is +1. Plug in 2, I'm also going to get +1. So let's graph that. I get -2 is -1, -1. 0 is a big empty space. And then on the right side, I get 0, +1, +2, and it's going to keep going here. So one thing we didn't really talk about before is your left and right limit have to agree for your limit to exist at that point. So if we look at our graph, our left and right limit don't agree because from the left, we're approaching at 0, we are approaching -1. But from the right, we approach +1. So it does not exist. There's another example underneath this one. Let's switch a color. But the limit as x approaches 0 from the positive direction, and I'm just going to write f of x this time. So from the positive way, again, we're going this direction. As x approaches 0, we're always 1. So our limit there is +1. From the other way, so as we approach 0 from the negative side, so we're going this way, hey, we go to -1. This is our right limit. And this one is our left limit. We won't deal with these a lot more in class than now. If you were to go on in calculus, you would see these more, but just it's helpful to know if you run across one of these, what to do with them. So we can talk about either direction limit. I forgot to write the name. There we go. Well, we can look at from either direction, but itself doesn't exist. Okay. This pops up a lot with piecewise functions. And so a piecewise function is a function that has a breakdown. So you have like two different functions, x is greater than something, x is less than. Your function is literally in pieces. Sometimes it works nicely, sometimes it doesn't. You'll come across some that don't work nicely because we do work in a real world, and real world does that sometimes. So here, if I were to take the limit as x approaches 0, the left and right limit agree. They both go to 1. So we have to look at both functions for this. If it were any other place, so say we were looking at limit as x approaches -1. -1. So the negative's in front of the sign, it means a -1. If it's after the number, that's our different limit. So that happens right here. And it looks like we also get -1. Did I write that down right? Yeah. So just a thing to watch out for. Sometimes there's a jump, so you'll get, whoops. A jump like that. In that case, the limit would not exist at 0. It would exist every place else, but not at 0. All right. Excuse me. Our last bit are unbounded limits. So I drew a function here, which is our f of x, is kind of the thing that's written down there 3 times. 3 over x minus 2. Yeah, seems right. So you'll notice the limit as x approaches 2, which is where our asymptote is. Hopefully you remember what those are. As x approaches 2 from the negative direction, we are going down and we never stop going down. So this gives me -infinity. Let me move some stuff. I'm sorry. Over here. So we're always going down. We're going to go down to infinity. As x approaches 2 from the positive direction, so we're coming from over here, like that. We're always getting bigger and bigger and bigger and bigger, so we get positive infinity. The left and right limit do not agree, so the limit there doesn't exist. If you were to have a function where it goes up, we can say the limit is infinity, but it's really hard to think about that in those terms. So usually we just say the limit doesn't exist when it goes to infinity. For us, it's not super useful. Again, if you take more calc, it might be, but we're not going to worry about that here. Okay, I think that was it. I don't know why I couldn't have stuck that in the end of the other video, but alas. Again, I will post these. Let me know if you're having trouble with them. I'm sorry about my handwriting. I promise it will get slightly better as the semester goes. I'm out of practice with my pen. Later today or probably tomorrow, I'll get the 1.6 videos up. Going forward, I might not do a video per section, but per concept. So if one concept covers 2 sections, we'll do that. If one section has 2 different concepts, we'll split it up. And I'll link you some other really good resources too, because my explanations aren't always the best for everybody. So find something. That said, Google is your friend. Find another explanation of how to do these problems. Go visit the Achievement Center if you get stuck on some of them too. You have lots of resources, so don't forget to use them. All right, I'm going to end this video once I figure out where the button is. Bye.